So welcome to Maths Memory Side 1 on your revision card, and this is your lesson on recurring decimals. So we're going to learn how to convert recurring decimals into fractions, a very typical non-calculated question. Let's look at the first key objective. We have basic recurring decimals. How to convert a basic recurring decimal to a fraction. And number 2, advanced recurring decimals. These two key objectives are very simple, in fact, if you learn the methodologies. This is week 12 over here, so it's week 12. And this is a grade 6 stroke 7. Again, like all the lessons in this, we leave a space for your favorite questions in this lesson, and steps 1, 2, 3, what you find very important from this lesson over here. So let's turn over, please, and let's create our toolkit. So on the other side, let's create two separate sections, A and B. This is where you're going to create your favorite methodologies, important points for this topic. So let's get back to basics. Question 1, back to basics. Press pause, write parts A and B down, and press play when you're ready. So this is quite an easy question, which gets you familiar with the basics of this topic over here. So change 3/8 into a decimal. So this you may have done quite a long time ago. We're going to get familiar with this once again. So this we call it an advanced fraction because we can't do it straight away. It's not one of the familiar ones we know off our head. So basically the denominator goes outside, and the numerator inside over here, and we're going to put dot 0, 0, 0, 3 zeros because we want this answer to 3 decimal places. So this is the bus stop method, or short division as we call it. So how many 8s are in 3? We can't do that. We'll put a 0. The dot always goes above here. We carry forward the 3. How many 8s are in 30 over here? This will be 3, remain a 6. How many 8s are in 60? This will be 7, remain a 4. And how many 8s are in 40? It's 5. So the answer is 0.375. This is how you do any kind of advanced fraction, which you can't really do firsthand. Use the bus stop method, 0.375. Let's get to part B. So prove that 0.27 recurring is this fraction over here. So this is quite a standard kind of question, the one we're going to be tackling within this topic. So this is called a basic one because all numbers here are recurring. This is like saying 0.272727. So let's call this x first of all. X, or 1x. 1x equals 0.27 recurring. So now we want to look at this decimal and see how many numbers, or digits rather, this number is recurring. So this is recurring over 2, because if we look at this, it's going over 2 numbers, the 2 and the 7. 1, 2 over here. 1, 2. So that's going to be basically, we're going to think, how do we get the decimal from here to here? We're multiplying it by 100, okay? So if you times the right-hand side by 100, we're going to times this by 100 as well. 100x equals 27.27 ... It's very important to have a number after the decimal. And one set is enough for this, which is the 277. So we've got this, and we've got this now, okay? We're highlighting the yellow bits because that's what you want as standard when you do this. You want the same numbers after the decimals for both of these over here. So now let's put a line over here and let's take them away from each other. So if we do this, we'll take them away from each other. So bottom take away top. So 100x take away 1x, 99x, and 27.27 recurring, take away 0.27 recurring. These cancel over here. This and this cancel. So we simply get 27. The answer will be 27 over 99. So you need to put the method for this, but that is the key understanding of how we can create a fraction from a recurring decimal. So press pause, write this example down in your toolkit. This is a very important example of basic recurring decimals just done on 100x. T stands for total. Write this down, press pause. Question 1, cool one. Press pause, write this question down. Press play when you are ready. So this question is all about converting a recurring number into a fraction. Take note that we have a recurring sign, a dot and a dot on the first and last digit of this number. This simply means 0.254, 0.254. It's the same as saying basically dot, dot, dots. So don't worry if you don't see all 3 dots in every digit. The first and the last digit, it will suffice to make it mean recurring. Let's first of all write 1x or x equals 0.254. And we'll basically look at how many times this digit is recurring until it repeats itself. So it's 3 times. It's 3 digits on a recurring basis. So basically, let's look at this as 1000x. 1000x, we're going to write over here because we have 3 digits recurring. So this will be 254.254, and we'll put the dots over here. Let's now take away from each other these 2 numbers. So we're going to be doing 1000x, take away 1x. This is going to be 999x, and this is going to be 254. A nice whole number over there. Take note how everything after the decimal over here and the decimal over here are the same. 254 recurring, and that's what you want already to cancel them out. If it's not, then obviously look back, it may have gone wrong somewhere. 999x equals 254, very simple. X equals 254 over 999. I assume we can't break that down any further, only because we have an even and an odd number over here. So that's your final answer for this question. Question 2, core 2. So press pause, write this recurring decimal down, try to get this as its simplest form possible as a fraction, and press play when you're ready. So this recurring decimal has 2 different elements, as you can see. We have a fixed part, let's call it the 0.4, and we have a recurring part, these 2 digits over here. So that's what makes it a difference over here, and we're going to call this advanced recurring decimals. It's advanced because it has 2 parts. One is a fixed element, 1 digit in this case, and one is a total number of digits, which is the fixed plus the recurring bit over here. So F and T. So let's see what we can do with this. So we have F, we have the fixed part. Now, how do we get the decimal from here to over here? This will simply be 10x. 10x equals 4.36. And let's look at the total part over here. How do we get the decimal from here right to the end after 6? 1, 2, 3. So that will be 1000x, and that will be the same thing as saying 436.36 recurring. So these are 2, let's say, equations over here. Now we take one away from the other, bottom take away top. Let's do this. Let's just put a little green sign over here and a yellow one, just to make sure you understand the different key for the first time hitting this advanced recurring decimal. Let's take away them from each other. So 1000x take away 10x, 990x. And we take away this from this, we get 432. Notice the way that after the decimal, we have a nice recurring bit after this, so we can cancel them out. Always look for that. 432 over 990. 2 nice even numbers. We'd like that. Can we do anything with 2 even numbers? Let's keep dividing this by 2. Let's say 216. Here we go. 216 over 495. Okay, now can we do anything with that to get to this number over here? Let's divide it by 9. Now, obviously, this is trial and error. You need to do your working out for this. But let's say if we did divide this by 9 and 9, we would get, let's test it in fact, 9 into 216. So 9 into 21, we get 2, remainder 3, 4. And in the denominator, 9 into 495. 9's in 49. That is 5, remainder 4. There we go, 5, remainder 4. How many 9s are 45? 5. So we have a final answer of 24 over 55. This is snap with what we have over here. So that would be our final answer for this advanced recurring decimal over here. There we go. So this is section B in our toolkit. So let's press pause again and let's write this advanced recurring decimal example down. The only difference here is we have a fixed bit, i.e. a one-off bit, and the total bits. Again, it's a fixed methodology. Press pause, please, and write this important advanced recurring decimal example down. Question 3 challenge. Press pause, write this question down, press play when you are ready. So express 0.3 to 6 recurring as a fraction in its simplest form. So the first thing we have to decide, is this going to be an advanced or a basic recurring decimal? Now, this is definitely going to be advanced because we clearly have two digits which are one-offs over here, fixed, and we have a recurring digit over here, 6 recurring, which obviously gives it the element of two different parts to this. So let's look at this. We have, first of all, the fixed part, which is 0.32, and the total part, 0.326 recurring. So we can write F and T to show us those two different parts to this decimal. So let's get more specific over here. So the fixed version. So how do we get from the decimal from here to the end of 2? Because we want to look at the fixed bit first. This will be, obviously, you times it by 100. So 100x equals 32.6 recurring. Let's take the total number now. We have 3 digits for the decimal to get to right to the end. So 1000x equals 326.6 recurring. So let's take these away from each other over here. Let's see what we get. So we have 1000 take away 100. So 1000 take away 100 would be 900x, and 326.6 recurring take away 32.6 recurring, 294. We're very lucky as well that the 0.6s, obviously, they cancel out. We should always make sure that they do. So let's have a look and see. Now, so x would definitely be 294 over 900. That's your final answer. Now we want this in the simplest form, so perhaps we can divide each by 2. This is where you have to do a bit of trial and error. Okay, so how many 2s are in 2, 1, 4, 1, 7, and how many 2s are in 900? Well, this is actually 450. So we could say this is the same thing as 147 over 450. Can we go even lower? Well, let's probably try 3. 3 and 2 are 147. How many 3s are in 14? That's 4, remainder 2, and that's going to be 9. How many 3s are in 450? This will be, well, we can see that's 150 straight away. So this can be written as 49 over 150. So that would be your final answer in this full broken down version of how you would write this fraction in its simplest form. So this brings us to the end of this lesson called recurring decimals. So you should have picked up 2 different key defining features of this. The first being basic recurring decimals, which just involves a recurring decimal, and the second one, advanced, which involves a one-off number, or a fixed bit we called it, and a total bit as well. So look through your notes. This was a space for you to actually write your examples. The 3 steps we've defined over here are such. So first of all, is this basic or advanced? Decide that by looking at actually the recurring bits on the numbers. Secondly, apply your formulas on that and simplify your final answer to break it right down. Let's turn over now to look at that toolkit of the key features of this lesson so you can apply this to our Let's Do It questions. So we should have now 2 sections clearly filled in at the end of our revision card, end of the session. And these are the 2 sections A and B. One's basic and one is advanced. So make sure you have these 2 things written down, and these should serve you in good stead now for our Let's Do It questions. So press pause, look at these, memorize these, and understand them more importantly, and let's go for this Let's Do It section. Question 1, let's do it. So press pause, write this decimal down, and press play when you are ready. Question 2, let's do it. So press pause, write this question down, and press play when you are ready. Question 3, let's do it. Press pause, write this question down, and press play when you are ready. So congrats, you now have finished recurring decimals on this topic. You should have a good idea of basic and advanced recurring decimals and how to convert them into fractions. So look back, look at the mark schemes, make sure you understand everything from your revision cards, and more importantly, rate yourself on your feel-good factor on your revision planner. So well done.